Hello everyone. Today, Teacher Sunny is going to talk to you about a concentration problem. This type of concentration problem hasn't been discussed before. We haven't talked about concentration problems yet. So now, let's take a look at how to solve it. We'll use a method that combines modeling to solve this problem. Of course, we'll also apply thinking strategies like equivalent transformation or quantity correspondence to tackle this question. First, let's read the problem together. Oh, a refreshing, cool cup of salt water. The salt in the salt water is 1/8 of the total. After adding 4 grams of salt, the salt becomes 1/6 of the salt water. The question is, how many grams of salt water were there originally? Alright, let's take a look. So, according to the problem statement, salt water. That is to say, salt plus water. It represents 1/8, which specifically means that this salt water solution can actually be evenly divided into 8 distinct parts. It can be split into 8 perfectly equal parts. Alright. We can certainly start over if needed. So 1 part out of 8 means that the salt truly takes up 1 distinct part of the entire saltwater solution. That is to say, the salt actually occupies 1 specific part. So 1/8 is salt and the water makes up the other 7 parts. You can think of it this way. Then, after that, we add precisely 4 grams of salt. Yes, indeed, add exactly 4 grams of salt. After that, the salt then becomes precisely 1/6 of the total saltwater mixture. In other words, afterwards, the entire saltwater solution can be evenly divided into 6 parts, and among these 6 parts, the salt takes up 1/6, which is 1 part, right? The rest is water, so water occupies 5 out of the 6 parts. Alright, from this we can see that what remains unchanged, that is the water. So, the total amount of water stays the same. So what does this tell us? This is indeed the very significant amount of water that is present right here, and this is also the substantial amount of water that is located over here. Here there are 7 triangles representing the water. And after adding precisely 4 grams of salt, the overall amount of water, which is still 5 parts, remains exactly the same. The total amount of water does not, in fact, change. Alright, next, we also know about the salt portion, the salt itself. It originally takes up 1 part, and after adding 4 grams, it still originally takes up 1 part. But after adding 4 grams, it becomes 1 out of 6 parts. That's how it is. Alright, so now we can start solving the problem. First of all, 1 part of the circle minus 1 part of the triangle equals 4 grams. We can get the amount and ratio. The amount is 4 grams. Divided by this fraction, what is the fraction here? We just take 1 out of the 5 equal parts here, which represents a fraction of 1/5. If we consider this particular section as a complete and single unit representing the whole of something larger, then subtract the triangle, which is here. 1 out of 7 parts is 1/7. In this way, we can get the result. 4 divided by 2 over 35, since 7 minus 5 equals 2. Alright, so we get a total of 70 grams, which means that the value of 1 unit here is 70 grams. So this crucial value has been determined. Seven triangles equals 70 grams. Each triangle equals 70 grams. So a triangle is essentially equal to 70 divided by 7, which is clearly equal to 10g. So this is the very truly original one. How much salt water exactly do you need? It is equal to 8 small triangles. that is to say, 8 triangles to be honest, are indeed equal to 80 grams. So we can accurately calculate the original saltwater solution. Okay, then what if we were to consider this particular situation? If I use equivalent substitution and substitute this one in, is that okay? Equivalent substitution works, it's also doable. You can try it yourself and you'll be able to solve the problem. Alright, have you learned it? If you have, please give Teacher Sunny a like, follow, and share this with more friends so we can all learn together.